Hello everyone, I'm Professor Diwa, and welcome to a math video on solving quadratic equations by completing the square. Our objectives are to use the square root property to solve quadratic equations, write perfect square trinomials, solve quadratic equations by completing the square, and use quadratic equations to solve problems. Alright, so let's get started. First, we have the square root property. It states here, if b is a real number and if a squared equals b, then a equals plus or minus the square root of b. In the next set of examples, I'm going to show you how we can use the square root property to solve quadratic equations. In example number 1, solve. For part A, we have x squared equals 25. To solve this equation for x, we need to get rid of the square by using the square root property. We just take the square root of both sides of the equation. The square root of x squared is just x, and the square root of 25 becomes plus or minus 5. So the result is x equals plus or minus 5. Next, we write our final answer in set notation, so I have a set of curly brackets and negative 5, 5 on the inside. Moving on to part B, we have 3x squared plus 60 equals 0. In order to solve for x, we need to subtract 60 from both sides of the equation. The result is 3x squared equals negative 60. The next step is getting rid of the 3 by dividing both sides by 3. 3x squared divided by 3 is x squared. Negative 60 divided by 3 is negative 20. So the result is x squared equals negative 20. Next, we need to solve for x by getting rid of the square. We just use the square root property and take the square root of both sides. Taking the square root of x squared, we get x, and taking the square root of negative 20, we get plus or minus I root 4 times root 5. So the result is x equals plus or minus I root 4 times root 5. Next, we could take the square root of 4, which is 2, so the result is x equals plus or minus 2I root 5. From here, we write our final answer in set notation, so I have a set of curly brackets and negative 2I root 5, 2I root 5 on the inside. For part C, we have parentheses x minus 2 squared plus 25 equals 0. In order to solve for x, we first need to get rid of the 25 by subtracting 25 from both sides of the equation. The result is parentheses x minus 2 squared equals negative 25. The next step here is using the square root property to get rid of the square. Taking the square root of parentheses x minus 2 squared cancels out the square, and then we have x minus 2. Taking the square root of negative 25, we could simplify this to plus minus 5i. The result is x minus 2 equals plus minus 5i. Next, we solve for x by getting rid of the minus 2. We just add 2 to both sides of the equation. The result is x equals 2 plus or minus 5i. For the final answer, we write it in set notation, so I have a set of curly brackets, and I wrote 2 plus 5i, 2 minus 5i on the inside. Next, we have a practice problem, solve. For part A, we have x squared equals negative 48. For part B, we have 3q squared plus 27 equals 0. For part C, we have parentheses y plus 5 squared plus 24 equals 0. Alright, so go ahead and pause the video, solve each problem, and check back with the video to see the solutions. Alright, so let's get started with part A. So the first step is to take the square root of both sides of the equation. Taking the square root of x squared, we get x. Taking the square root of negative 48, we get plus minus I root 16 times root 3. The result is x equals plus minus I root 16 times root 3. Next, we take the square root of 16, which is 4. The result is x equals plus minus 4I root 3. Next, we write our final answer in set notation. So I have a set of curly brackets, and then we have negative 4I root 3, comma 4i root 3 on the inside. For part B, I started off by subtracting 27 from both sides of the equation. The result is 3q squared equals negative 27. The next step is getting rid of the 3 by dividing both sides by 3. 3q squared divided by 3 is q squared, and negative 27 divided by 3 is negative 9. So the result is q squared equals negative 9. From here we get rid of the q squared by taking the square root of both sides of the equation. We have the square root of q squared is q, and the square root of negative 9 is plus or minus 3i. The result is q equals plus or minus 3i. Next we write our final answer in set notation, so we have curly bracket, negative 3i, comma 3i, close curly bracket. For part C, we need to solve for y, so we need to get rid of the positive 24 first by subtracting 24 from both sides of the equation. The result is parentheses y plus 5 squared equals negative 24. Next, we get rid of the square by taking the square root of both sides of the equation. Taking the square root of parentheses y plus 5 squared will give us y plus 5. Taking the square root of negative 24, we get plus minus I root 4 times root 6. So the result is y plus 5 equals plus or minus I root 4 times root 6. Next, we could take the square root of 4, which is 2. The result is y plus 5 equals plus or minus 2i root 6. Next, we need to get rid of the 5 by subtracting 5 from both sides of the equation. The result is y equals negative 5 plus minus 2i root 6. Now for our final answer, we're going to write this in the proper format for a complex number, which is a plus bi. So for our final answer, in set notation, we write a set of curly brackets, and on the inside, we write negative 5 minus 2 root 6i, comma, negative 5 plus 2 root 6i. Next, we're going to go over the process for completing the square. When we're talking about completing the square, we're actually talking about creating a perfect square trinomial and then factoring it as the square of a binomial. So let's start off with two perfect squares. We have parentheses x plus a squared is equal to x squared plus 2ax plus a squared. We also have parentheses x minus a squared is equal to x squared minus 2ax plus a squared. Notice here for perfect squares, it doesn't matter whether they're in the form x plus a squared or x minus a squared. The middle term of the trinomial, the coefficient specifically, will always be 2a. And then the third term, or the last term of the trinomial, is always a squared. This property is what we're going to use to complete the square. So now let's go over the process for completing the square. So over here I have parentheses x, a blank space, and a square on the parentheses is equal to x squared plus 14x, plus, and then a blank space. What we need to do here is complete the square by filling in the missing values. So what we're going to do now is use the property that the middle coefficient of a perfect square trinomial will always be equal to 2a. So we have 14x in the middle. We just take 2a and set that equal to 14. Next, we need to solve for a by dividing both sides by 2. 2a divided by 2 is a, and 14 divided by 2 is 7. So we get a is equal to 7. Next, we know that the last term of a perfect square trinomial is always a squared. So we take our value for a and square it. So we have a squared is equal to 7 squared, which is just going to be 49. Next, we take our value for a and substitute it into the blank space on the left side of the equation. And then we take our value for a squared and substitute it into the blank space on the right side of the equation. So we have parentheses x plus 7, a square on the parentheses, equals x squared plus 14x plus 49. And now we finished completing the square. Let's go over another example. Here I have parentheses x, a blank space, a square on the parentheses, equals x squared minus 5x plus, and then a blank space. So we need to complete the square by filling in the values that go into the blank spaces. Alright, we know that the middle term of the trinomial, -5, is always equal to 2a. So I have 2a equals -5. Next we solve for a by dividing both sides by 2. We get 2a divided by 2 is equal to a, and -5 over 2 is just -5 halves. So a is equal to -5 halves. Next we just square our value for a, so a squared is equal to 5 over 2 squared, which is just 25 over 4. And now we fill in the blank spaces. So -5 halves goes on the left side of the equation, and 25 over 4 is the third term of our trinomial. So we have parentheses x minus 5 over 2 squared equals x squared minus 5x plus 25 over 4. Now that we finished completing the square, notice here that all we did to complete the square was take half of the middle coefficient, square it, and then use those values to complete the square. So you don't have to write out all of the steps that you see here. You can just take half of the middle term, square it, and then complete the square. Next, we're going to go over the entire process for solving a quadratic equation in X by completing the square. The first step is to isolate the terms with variables on one side of the equation and arrange them in descending order. The second step is divide both sides of the coefficient of x squared if that coefficient is not 1. The third step, complete the square by taking half of the coefficient of x and adding its square to both sides. The fourth step, express the trinomial as the square of a binomial, factor the trinomial. The fifth step, use the square root property to solve for x. In the next set of examples, I'm going to show you how we apply these steps to solve a quadratic equation. For example number 2, solve by completing the square. For part A, we have x squared plus 16x minus 57 equals 0. The first step is to isolate the terms with the variables on one side of the equation by getting rid of the minus 57. So we're going to add 57 to both sides of the equation. The result is x squared plus 16x. I'm going to leave a space here for completing the square, equals 57. The second step we could skip because the coefficient of x squared is 1. So we go directly to step 3 and complete the square. So we just take half of 16 and square it. 16 divided by 2 is 8. The square of 8 is 64. From here we add 64 to both sides of the equation. So the result is x squared plus 16x plus 64 equals 57 plus 64. For the next step, we need to express the perfect square trinomial as the square of a binomial. This will be parentheses x plus 8 squared. We also need to simplify the right-hand side, so we have 57 plus 64 is 121. The next step is to use the square root property to solve for x. So we take the square root of both sides of the equation. On the left-hand side, the square root of parentheses x plus 8 squared is just x plus 8, and on the right-hand side, the square root of 121 is plus or minus 11. The result is x plus 8 equals plus or minus 11. The next step is subtracting 8 from both sides of the equation. The result is x equals -8 plus or minus 11. If we simplify, we get two different values for x. -8 minus 11 is -19, and -8 plus 11 is 3. So we get x is equal to -19, and we have x equals +3. For our final answer, we write it in set notation. So I have a curly bracket, -19, 3, close curly bracket. Moving on to part B, we have 4x squared minus 5 equals 2x. Again, the first step is to isolate the variables on one side of the equation. So I'm going to do two steps at once. I'm going to subtract 2x from both sides of the equation and add 5 to both sides of the equation. The result is 4x squared minus 2x equals 5. The second step is dividing both sides of the coefficient of x squared because the coefficient is not 1. So we need to divide each term in the equation by 4. Simplifying the first term, 4x squared divided by 4 is x squared. Simplifying the second term, negative 2x over 4 is negative 1/2 x. And then for the last term, 5 over 4 is just 5 over 4. So the result is x squared minus 1/2 x, and then I'm leaving a space here for completing the square, equals 5 over 4. The next step is completing the square. So we need to take half of negative 1/2, we get negative 1/4, and then we square it. So the square of negative 1/4 is positive 1/16. So we just need to add 1 over 16 to both sides of the equation. The result is x squared minus 1/2 x plus 1 over 16 equals 5 over 4 plus 1 over 16. For the next step, we need to express the perfect square trinomial as the square of a binomial, and then we also need to add 5 over 4 and the 1 over 16. The result is parentheses x minus 1 over 4 squared equals 21 over 16. From here, we need to solve for x by using the square root property, so we take the square root of both sides of the equation. So on the left-hand side, the square root of parentheses x minus 1 over 4 squared is just x minus 1 over 4. On the right-hand side, we could rewrite the square root of 21 over 16 as plus or minus the square root of 21 over 4. The next step is adding 1 over 4 to both sides of the equation. The result is x equals 1 over 4 plus or minus the square root of 21 over 4. Now we need to write our answer in set notation, so I have a set of curly brackets, and on the inside I wrote 1 over 4 minus square root of 21 over 4, comma, 1 over 4 plus square root of 21 over 4. Next we have a practice problem, solved by completing the square. For part A, we have x squared plus 6x minus 7 equals 0. For part B, we have 2x squared plus 3 equals negative 4x. Alright, so go ahead and pause the video, take your time working out this problem, and then check back with the video to see the solutions. Alright, so let's go over part A. The first step is adding 7 to both sides of the equation. The result is x squared plus 6x, we leave a space for completing the square, equals 7. Next we take half of 6, square it, and then add it to both sides of the equation. Half of 6 is 3, and then squaring 3 we get 9. So we need to add 9 to both sides of the equation. We get x squared plus 6x plus 9 is equal to 7 plus 9. Next we could express the perfect square trinomial as a square of a binomial, which is parentheses x plus 3 squared, and then we also need to add the 7 plus 9, which is 16. So the result is parentheses x plus 3 squared equals 16. Next we need to solve for x by getting rid of the square. We just use the square root property and take the square root of both sides of the equation. The result is x plus 3 equals plus or minus 4. Next we subtract 3 from both sides of the equation. We get x equals negative 3 plus or minus 4. Now we need to write our answer in set notation, which is curly bracket, negative 7 comma 1, close curly bracket. For part B, we need to isolate all the variables on one side of the equation, so I did 2 steps at once. I added 4x to both sides of the equation, and I subtracted 3 from both sides. The result is 2x squared plus 4x equals negative 3. Next, we need to get rid of the coefficient in front of x squared by dividing both sides of the equation by 2. Starting with the first term, 2x squared divided by 2 is x squared. For the second term, 4x divided by 2 is 2x, and for the last term, negative 3 divided by 2 is negative 3 over 2. So the result is x squared plus 2x, leave a space for completing the square, equals negative 3 over 2. Next we complete the square. We take half of 2, square it, and then add it to both sides of the equation. Half of 2 is 1, 1 squared is 1. From here, we add 1 to both sides of the equation. So we get x squared plus 2x plus 1 equals negative 3 over 2 plus 1. Next, we could express the perfect square trinomial as a square of a binomial, and then we add negative 3 over 2 and 1 together. The result is parentheses x plus 1 squared equals negative 1/2. Next, we need to solve for x by getting rid of the square. We just use the square root property and take the square root of both sides of the equation. So the result is x plus 1 equals plus or minus I over root 2. The next step here is getting rid of the root 2 in the denominator by multiplying the top and bottom of the fraction by root 2. Essentially, we're just rationalizing the denominator. The result is x plus 1 equals plus or minus I root 2 over 2. Next, we get rid of the positive 1 by subtracting 1 from both sides of the equation. The result is x equals negative 1 plus or minus root 2 over 2i. Our final answer in set notation is curly bracket negative 1 minus root 2 over 2i, comma, negative 1 plus root 2 over 2i, close curly bracket. For example number 3, use the formula a equals p times the parentheses 1 plus r raised to the t power to find the interest rate r if $2,000 compounded annually grows to $2,420 in 2 years. In order to find the interest rate r, we just go ahead and plug in the values they gave us into the compound interest formula. So starting with the compound interest formula, we have a equals p times the parentheses 1 plus r raised to the power of t. T represents the number of years that the money is invested, which is 2. P represents the initial investment or the principal, which is $2,000. And A represents the total amount of money after the investment period, which is $2,420. Next, we substitute the values into the equation. We get 2,420 equals 2,000 times the parentheses 1 plus r squared. Next, we divide both sides by 2,000. The result is 1.21 equals parentheses 1 plus r squared. Next, we use the square root property and take the square root of both sides of the equation. The result is plus or minus the square root of 1.21 equals 1 plus r. Next, we solve for r by getting rid of the positive 1. We just subtract 1 from both sides of the equation. The result is r equals negative 1 plus or minus the square root of 1.21. However, we could eliminate the negative 1 minus square root of 1.21 because that would result in a negative interest rate, which would not make any sense for this problem. So r is equal to negative 1 plus the square root of 1.21. If we plug this into a calculator and round to 1 decimal place, we get that this is approximately equal to 0.1. Next, we convert the decimal to a percentage, which is just multiplying it by 100. This results in 10%. So the final answer is that the interest rate is 10%. Alright, so this is the end of our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.